Hi everyone. So next, I want to compare this regression tree results with linear model. So linear model is usually the baseline. So it's good to compare it with this. So in a data competition website such as Kaggle, usually if you use just linear model, you are usually the 10th percentile of all participants. So some participants submit some file by error or something. So still you can beat 10%, but it's not fantastic. So that is a good baseline. So compare with the linear model. So remember that we are using the car seats sales data. So we fit the car seats sales data. So we transform the car seats data into numeric. So maybe we refresh the data. So maybe we remove the data, and again we use the original default car seats data. Okay. So car seats data is included in ISLR package. So even if you remove it, still it exists, and it becomes factor again. Okay, so linear model. So LM, we fit sales on all other predictors, and we only use the training set. So car seats of training. So LM is here, and okay, so we want to remove redundant variables. So we do stepwise procedure. So stepwise AIC. So this is backward deletion, backward deletion algorithm. So then we removed several variables, and we keep income, advertisement, age, and the competitor's price, and the price and the shelf location. So this is factor. So we have 2 degrees of freedom. We have 3 categories. So summary of the final model. Yeah, actually all 6 variables are significant, very significant, even though the scatter plot doesn't indicate much. Okay, so this is pretty good result. And now we want to do prediction. So LM training prediction. So predict just LMS. So then we use the training set. And what is the mean squared error? So LM TRN, so this is predicted numbers, and actual numbers are defined last time. So TRN. So we take square of this residual and take average. So this is training error. So MSE, mean square error for training set. And actually this is 1.04. This is pretty small. So in fact, this is much better than regression tree. But this is training set, so how about test? So test is, again, the predict LMS, the stepwise, so the regression model by stepwise AIC, but we use the new data, the test data, so car seats of test. Then you can do the same thing as last time, but for test set. Then you can get the mean squared errors for test set, and you can get actually 1.0574. This is pretty good. It's almost comparable to training set. So we are somewhat lucky, but linear model works really good. So last time, remember that we get the training error of 2.56 and the test error of 5.18. So as discussed in the textbook, usually the naive, the tree methods perform worse than linear model, even though interpretation is pretty intuitive, such as we split by price at some point. Okay, so so this is the demonstration of the tree-based method in chapter 8.1. Okay, see you then.